everyone. My name is Abhishek and I'm maths faculty here at askIITians. So this is lecture number 2 of chapter mensuration. And before we move to the topics that we are going to cover in this session, let us go through the weightage of this particular chapter, both for school examination and for Olympiad examination. So if you talk about school examination, then you can expect questions carrying around 11 marks from this particular chapter. Although from school to school, there might be little variation as in NEET standard, the examinations that are conducted, they are internal examinations of the school. On the other hand, if you talk about Olympiad examination, then in Olympiad examination, 3 to 4 questions can be expected from this particular chapter. And this chapter is very important for the it's very important not because it has good weightage in school examination and Olympiad examination. It is very important because you will come across mensuration topic again in 9th standard and 10th standard. So be very attentive while we cover any topic because it will be helpful to you in the classes that you will be appearing in the next 2 years. So what topics are we going to cover in today's session? In today's session, we are going to cover these 3 topics. The first topic is we are going to discuss the area of any general quadrilateral. Okay, and then we will discuss the area of rhombus. After that, we are going to discuss the area of any polygon. Okay, and the third is we are going to discuss what are solid shapes. All right, and we will try to derive the result wherever possible. Apart from that, we will also learn the application of these formulas or the topic that we are going to cover in today's session. So let's start with the very first topic. So here we have area of any general quadrilateral. So here the quadrilateral that is provided to us, it is any general quadrilateral. That means we do not know anything or there is no relation as such between the 4 sides that we have of this quadrilateral. That is AB, BC, CD, AB, BD, DC and AC. And we don't know and if there is any relationship between the diagonal. So if you come across some such situation, then how you can find out the area of the quadrilateral, that is what we are going to discuss in today's session. So here, what is given? We are given a quadrilateral. Check out. Okay. So what are we given? We are given a quadrilateral. You are given a quadrilateral ABCD. You are given a quadrilateral ABDC. All right. And what we have to do, we have to find out the formula for the area of this quadrilateral ABDC. So we need to do one construction. And what is that construction? You need to draw 2 altitudes. One of the altitude will be drawn from this vertex A to this diagonal BC. And the other altitude will be drawn from this vertex D to this diagonal AC. So first, what is the construction that we need to do? We need to do 2 construction. One of the construction is you need to join BC. Okay, any one diagonal will work. And what's the other construction? The other construction is you need to draw A, if I let us call this as M and that as N. Okay, you need to draw AM perpendicular to BC, and you need to draw DN that is perpendicular to BC. All right, that is D, guys. This is D. Clear? So now what will happen if you observe this figure very carefully? Now what is happening? This figure actually got divided into 2 triangles. One of the triangle is triangle ABC, and the other triangle which you have is triangle BDC. We can easily find out the area of both these two, both the triangles that we got. If we can find out the area of both the triangles and we add the area of both the triangles, you will easily get the area of the quadrilateral which is under consideration here, right? So proof, you can see here, if you want to find out area of this quadrilateral that you have, which is ABDC, then area of this quadrilateral will be equals to what? That will be equal to area of triangle ABC added to area of triangle BDC, right? To find out area of triangle ABC, we have this height, which is or perpendicular, that is, and the length of this height or perpendicular is equal to h1. And what is the base? Base you have is BC. So to find out, so area of triangle ABC will be given by 1 by 2 into base into height. So base is BC and height is AM. All right. And if you have to find out the area of the other triangle, which is BDC, then the height is DN and the base is same. So you will have 1 by 2 BC into DN. Clear? You can take BC by 2 common from both the terms that you have. If you take BC by 2 common from both of them inside the bracket, you will be getting AM plus DN. And what is the value of AM and DN? AM we have assumed to be equal to H1 and DN we have assumed equals to H2. So you are going to get BC by 2, okay? And this will be H1 plus H2. Clear? So that is the area of the quadrilateral which is under consideration here. I hope it's very clear to all of you. So what is the crux of this topic? The crux is that if you have to calculate the area of any quadrilateral, you can join any one of the diagonal. Here I have joined the diagonal BC, and after joining that diagonal, you can draw two, I would say, altitudes from the vertex which are opposite to it. Then you can find out the area of the two triangles which will be formed as a result of joining the diagonals. You calculate the area of triangles using, and we know how the area of triangle can be calculated. Area of triangle can be calculated by using the formula that is half base into height. If you calculate the area of both the triangles, add the areas of both the triangles, and you will eventually get the area of the quadrilateral which is under consideration here. Please go through this entire result that we have discussed and ask me if you have any query in this, guys. Yeah, that is DN. Correct. That's DN. All right, done. Okay. Now what do we have? We have to discuss how do we find out the area of any rhombus. Okay. We know what is a rhombus. Rhombus is a figure in which all four sides are equal. That's the first property, right? All four sides are equal. Okay. And what is the second property you have? The second property is diagonals bisect at 90 degree. Diagonals bisect at 90 degree. Okay. And apart from that, we have one more property that if you join the diagonals of the quadrilateral, the rhombus, then that rhombus gets divided into four congruent triangle. So here, let me give a name to this rhombus that I have. This is A, that is B, this one is C, and that is D. So what is going to happen if I join AC, okay, and if I join BD, these two diagonals that I have, then this rhombus which I have with me, it will be divided into four congruent triangle. So one of the triangle is delta 1, let's say. This is delta 2, that is delta 3. This one is delta 4. So here you are going to have delta 1 that will be congruent to delta 2, which will be congruent to delta 3, and that will be congruent to delta 4. And we also know that whenever you have any two congruent figures, then the meaning of congruent figures is that the area that is enclosed by that particular figure, like the figures which are under consideration, will also be equal. Clear? So what is the point of taking this? I discuss this point because we discuss, or we know that if when we are joining the diagonals of any quadrilateral, then any rhombus, then the rhombus is getting divided into four congruent triangle. So I can calculate the area of one of the congruent triangle that I have. I can multiply that area by 4. If I multiply it by 4, I'll automatically get the area of the rhombus which is under consideration here. Okay, so here we are going to do some construction. What is the construction? We are going to join the diagonals. So join AC and BD. AC and BD. All right. So I'm writing here the result which I'm going to use. Okay. So diagonals of a rhombus, as diagonals of a rhombus divides it into four congruent triangles. It into four congruent triangles. So that means what? That means if you want to find out the area of that means if you want to find out the area of this rhombus ABCD that I have, then that can be written as 4 times of area of any one of the triangle. And I am assuming the diagonals are bisecting each other at O. All right. And they bisect at 90 degrees. So that will be 4 times of area of triangle AOB. Correct. And area of triangle AOB can be calculated by using half base into height. So you are going to get 1 by 2 into base, which is OB, into height, which I have assumed to be OA. Right. Now OB will be half of BD, isn't it? Because the diagonals bisect at 90 degree. So I can replace it. So I will be having 4 into 1 by 2. OB is half of BD. Clear? And OA that you have, that is half of AC. Clear? This 2 and 2 will cancel this 4. So what I'm going to get? I'm going to get 1 by 2 into BD into AC, right? What is BD? BD we have denoted here by D2 and AC we have denoted by D1. So you are going to get 1 by 2 into D1 into D2, correct? So that means the area of any rhombus is given by 1 by 2 into product of diagonals. To product of diagonals. I hope this is clear to all of you. All right. So that is the formula we have whenever you have to calculate area of rhombus. So to derive this formula for the area of rhombus, we used the properties that we have for rhombus. So using those properties, we got the formula for the area of rhombus, which is 1 by 2 into product of diagonals. If you have any doubt or any query in this, please ask me. I'm giving you around 30 to 40 seconds to go through this entire solution once again. Does anyone have any doubt in this? Shall we move ahead? Okay. So now we have an example based on the topic that we discussed just now. What does it say? You have to calculate the area of rhombus and having diagonals equal to 6 centimeter and 8 centimeter respectively. All right. So here, let's say the rhombus under consideration here is A, B, C, D. Okay. And the diagonals we have is D1 and D2. Clear? So here we are provided the length of diagonals. Here you are provided AC, which is same as D1, that's equal to, let's say, 6 centimeter. Okay. You are provided BD, which is same as D2, that's equal to what? That's equal to 8 centimeter. These two values we are already provided in the problems. All right. We discussed just now what is the formula, or in fact, we derived that formula. Like what is the formula for area of any rhombus? If you have to calculate area of any rhombus, you have to use the formula that is half base into half into product of diagonal. Okay. Now, if you want to calculate area of this rhombus that you have, which is ABCD, then area of this rhombus ABCD will be 1 by 2 into product of diagonal, which is AC into BD. Correct? So what is AC? AC is D1, right? And what is BD? BD is same as D2. So if you substitute the value, you will get 1 by 1 by 2 into 6 into 8. So this 2 will cancel this 8 4 times. So you will be getting 6 into 4, and 6 into 4 is 24. So you are going to get 24 centimeter square as the area of the rhombus which is under consideration here. I hope this problem is clear to everyone. Please go through it. In case of any doubt, ask it, and then I will show you the solution also of this problem. Is it done? Okay, so here you can see the solution is for your reference, guys. We are provided one of the diagonals which they have denoted by D1, and D1 is equal to 6 centimeter. We have another diagonal that has been denoted by D2, that is equal to 8 centimeter. And the area of any rhombus is given by 1 by 2 times of product of diagonal. So you will substitute the value. After substituting the value, if you simplify it, you will be getting 24 centimeter square. And therefore, the area of this rhombus under consideration here will be 24 centimeter square. And we also got exactly same thing here. Clear? All right. So now we have area of any polygon. Any polygon means we are not now concerned with only quadrilateral, or we are not concerned with any with only triangle now. We are talking about any generic polygon. Okay, it can have 4 side, it can have 5 side, it can have 6 side, and so on. So what do we do in that? Okay, so basically, what is the meaning of area? Whenever you are defining area, then area of any polygon is actually the region which is occupied by that particular polygon in two-dimensional space. We all know that, right? And if you have to find out the area of any polygon, what you have to do is you have to divide that polygon into like by joining the different vertex that you have to join that polygon in, let's say, triangles, or some part into quadrilateral, and a few of the quadrilateral might be trapezium, few might be rectangle, few might be square, etc., etc. Basically, the division of the quadrilateral, the polygon whose area you have to calculate, needs to be done in the figure whose formula or whose area you are aware of. For example, you know the area of triangle, no matter what kind of triangle it is. You know the area of any, like almost every type of quadrilateral. So you can always divide the polygon which is given to you in triangle and quadrilateral, and after dividing that polygon into triangle and quadrilateral, we can apply the formula as per the requirement, and after solving it properly, you will easily get the area of polygon. I will show you an illustration in the very next slide. So before we move to that, let us quickly go through, or let us quickly revise what we need to use whenever we have to calculate the area of polygon. So if you are talking about triangle, then area of triangle is generally given by 1 by 2 base into height, but that varies. Like if you have equilateral triangle, then that is given by root 3 by 4 side square. Similarly, for isosceles triangle, we have a different formula. But if you talk about the generic formula that you have when it comes to calculating area of any triangle, then the generic formula that you have when it comes to calculating area of any triangle, that's 1 by 2 base into height. Okay, if you talk about square, we studied this yesterday in the last session, that the area of a square is always given by side square. If you are talking about rectangle, it is always given by length into breadth or width. Okay, if you talk about rhombus, we studied in today's session that the area of rhombus is always given by 1 by 2 into product of diagonals. Clear? And these two points are given from the point of view of competitive examination. Okay, if you can remember it, well and good. If you cannot, no need to worry. We can always divide, be it pentagon or hexagon, into a number of figures, and we can calculate the area of those figures, add the area of those figures, and you will easily get the area of whether the pentagon is given to you or hexagon is given to you. So if you talk about pentagon, then the area of pentagon is given by 5 by 2 into the length of its side multiplied by distance from the center of the sides to the center of pentagon. Clear? Means if you have a pentagon, then the area will be 5 by 2, which is multiplied by the length of the side of that pentagon which is under consideration. That is multiplied by the distance of the center of the sides to the center of pentagon. If you talk about hexagon, then that is given by 3 root 3 by 2 into distance from the center of the side to the center of hexagon, which is very similar to the area of pentagon. I will show you how you can find out the area of any polygon. I repeat, any polygon very, very, very easily. That I'll show you. Done. Okay, you can see this figure. Okay, this figure is a polygon, and how many sides does it have? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So it's a heptagon. Okay, so you have to find out the area of this polygon A, B, C, D, E, F, G. Okay, the measurements in centimeter are given. Clear? All right. So see, we have to find out the area of this entire figure. A, B, C, D, E, F, and G. All right. We do not have any direct formula to find out the area of this polygon that you can see on your screen. But what I told you, I hope you remember that I told you that you can always divide the given polygon into a number of small figures whose area you can easily calculate, right? So let us see what construction can we do here to do that. So I'm going to do some construction here. I'm going to join G and C. All right, so I'll get one trapezium. After joining G and C, I'm going to join F and D, which is again going to give me trapezium. And this one is triangle. So this figure is trapezium here. I'm mentioning here. This is trapezium. All right. This figure is also going to act as trapezium. Okay. And this figure is very clear. This one is triangle. Clear? And we know when it we know how to find out the area of trapezium and how to find out the area of triangle. We already know about all this. All right. So let me mention the construction that we did. So the construction is you need to join GC, FD. Okay, you need to join GC and FD. All right. Now let us see the proof. So if you want to find out area of this figure, which is A, B, C, D, E, F, G, what do you have to do? You can calculate area of this trapezium A, B, C, G. Okay, that is G. A, B, C, G. All right. You can calculate area of this trapezium, which is G, C, D, F. You can calculate the area of the triangle that you have, that is triangle FDE. You can add all the three areas. Okay. When it comes to area of this trapezium ABCG, okay, what are the values we have? Let us see. You have 1/2 into sum of parallel sides. So here AB that you have, it will be parallel to GC. The length of AB is equal to 4. So you will have 1/2 into AB, okay, plus GC. All right. And what is the height? Height is going to be this value. I'm going to denote by H1. Clear? Into H1. All right. If you have to calculate the area of this trapezium, then this GC, it will be parallel to FD. So you will have 1/2 multiplied by GC plus FD into height. What is going to be the height? Here height is going to be CD, you can say. All right. And when it comes to the area of this triangle, you have base, which is FD. So 1/2 into FD. And what is height? Let me draw height from here. That is H2. Clear? Height is H2. Now we have to substitute the values of these, like AB, GC, H1, GC, FD, CD, FD, H2. And you have to be very, very careful when you substitute these values, because even if you substitute one incorrect value, your answer is going to be incorrect. So be very, very careful. So let us substitute the value. So you will get 1/2 multiplied by AB plus GC. So what is AB? AB is 4. What is GC? GC is equal to 7. Okay. What is H1? I'm talking about this height, because this height H1 will be equal to 3. Clear? Plus, you are going to get 1/2 into GC. GC is equal to 7 plus FD. FD will be equals to 4 only. Okay. Because F got shifted by 1 unit. If you compare it, or if you compare it to the position of A by 1 unit to the right hand side. So it is also going to be 4. And what is CD? CD will be equal to 6 minus 3, which is equal to 3. Here you are going to get 1 by 2 into FD. FD is equal to what? FD is equal to this value. Okay, FD we already knew, that is equal to 4. And what is H2? H2 means this height. Since this complete value is 8, this value is 6. So F2 is H2 is 2. Clear? So what are you going to have? Here you will have 7 plus 4 is 11 into 3. That is 33 by 2. Clear? Your second value will be what? 7 plus 4 is 11 into 3. That is 33 by 2. Okay. And in the last case, what will happen is this 2 and 2 gets cancelled. So here you will be left with 4. This 2 will cancel this 33 how many times? It will cancel it 16.5 times. This 2 will cancel it how many times? 16.5 times. And this 4 will remain as it is. So what do we have? We have 16.5 that is added to 16.5 plus 4. Okay. And 16.5 when added to 16.5 gives you 33, and 33 plus 4 gives you 37. All right. So what is the required area? Your required area will be equals to what? That will be equal to 37 unit square. Okay. Here unit is centimeter. So you have to write centimeter square. 37 centimeter square. I hope this problem is very clear to everyone, and I hope you will not get scared just by having like if you come across a complex figure like this. Be very calm, be very patient, try to see if you can divide the given figure into a number of small figures whose area you can easily calculate, or at least you are aware of the formulas of the area of those figures. Then go ahead without hesitation, be confident you will easily get the answer. Please go through this solution again. Ask me in case of any query that you have. Is it done? So here you can see they have done it in the exact same way, guys. They calculated the area of trapezium ABCG by using the same formula, that is 1 by 2 into sum of parallel side into height. They substituted the value and they got 16.5 centimeter square. If you remember, we also got the same value. Thereafter, they calculated the area of CDFG, which is again 16.5 centimeter square. We also got the exact same value. And finally, they calculated the area of triangle DEF by using half base into height. They also got 4 centimeter square. We also got the same value. Now to find out the area of that figure, which we were, or that polygon which was given to us, ABCD, EFG, all you have to do is you have to add the areas of these three figures. That is area of ABCG, area of CDFG, and area of DEF. The area of these three figures needs to be added. If you do it properly, you will get the required area, which will be equal to 37 centimeters square. Okay, here you just need to practice few more problems like this, and you will easily get problems like this in NCERT also, as well as in some standard good books as well, right? So make sure that you practice few more problems based on exactly this concept, and you will feel confident in it. Like, it's super easy. Done? Okay. Now we have this last thing, which is solid shapes. What are solid shapes? Okay. So what are solid shapes? Solid shapes has three-dimensional figure, or you can say these are three-dimensional 3D figures. Okay. Means till now we were talking about two-dimensional figures. Two-dimensional figures means the figures which have got two dimensions only. For example, if you talk about let's say a rectangle, then rectangle has got only two dimensions, that is length and breadth. If you talk about cube, that not cube. If you talk about a square, it has also got only 2 dimension. If you talk about trapezium or any other figure that we discussed till now, they all were 2-dimensional figures, as they were having only 2 dimensions. One of the dimension was length and the other dimension was breadth. But if you are talking about solid shapes, the very first thing which you need to keep in mind is they are 3D figures, and 3D figures means they have got 3 dimensions. Okay, one of the dimension is length, one of the dimension is length, the other dimension is breadth, which is denoted by D, which is denoted by B. Okay, and the third dimension you have is height, that is denoted by H. That is denoted by H. So solid shapes are 3D figures or 3-dimensional figures. And what are the 3 dimensions? One of the dimension is length, denoted generally by L. The other dimension is breadth, that is denoted generally by B. And the third dimension you have is height, which is generally denoted by small h. Now, what are the other important points that we have? Their surface are called faces. So let me take one example here. So here, this, like I'm taking the case of rectangular prism that you have. So this is one of the face. Clear? That is one of the face. So these, like this, I'm going to name it A, B, C, D. Okay, A, B, C, D is one of the face. D, C, G, T, that is one of the face. So A, B, C, D, D, C, G, T, these 2-dimensional faces, or these 2-dimensional figures which makes up your 3D figures, they are called faces. And these faces, if you observe, they meet at edges. So let me highlight what edges are. So this is edge. Clear? This DC is one of the edge. This AD is one of the edge. Clear? This AB is one of the edge. This BC is one of the edge. Okay. So let me take an example of a cube, cuboid, for example. Okay. And in that case of cuboid, I'm going to discuss the total number of faces. What are faces? The total number of edges. What are edges as well? And what are vertices? I'm going to discuss all of them. So let me draw a cuboid first. All right, let's assume this is a cuboid you have. Clear? So in this cuboid, we are going to discuss 3 things. One is what are faces? Okay, faces. So let me name it. This is A, that is B, C, this one is D, this is P, that's Q, that's R, that S. So I'm going to shade what is face. Okay, so this A, B, C, D that you have, this is one of the face. Parallel to it, you have one more face, which is PQRS. Clear? Here you have on the right hand side one more face, which is DCRS. Apart from that, you have another face, which is ABQP. Okay, so overall, if I ask you how many faces does it have, so one at the top, one opposite to it, 2 faces. The second one here at the back, one exactly opposite to it, so 4 faces in total, and 2 on the lateral side. So overall, you are going to have 6 faces as far as your cuboid is concerned. Okay, so this is one of the face, that is one of the face. So these portions we call as faces. If you talk about edges, these faces, if you observe, like if I talk about face ABCD and if I talk about SRDC, then these 2 faces are intersecting or meeting each other here along this line DC. Then this DC that you have, or you can say DS that you have, or you can say QR that you have, all these are referred to as edges. Clear? All these are referred to as edges. So how many edges do we have here? How many edges do we have? Count here. 1 edge, second, third, fourth. Okay. Similarly, 5, 6, 7, 8. You will have 9, 10, 11, 12. So you are going to get 12 edges here. Understood? Now these edges that you have, they meet each other at a point, and we call that particular point as vertices. So A is one of the vertex, B is second vertex, C is third vertex, D is fourth. Similarly, P is fifth, Q is sixth, R is seventh, and S is eighth. So how many vertex do you have? You have you have 8 vertex. Clear? You have 8 vertex. Is that clear? That's what edges, faces, and vertices mean. And you can actually check it whether the number of faces, edges, and vertices you got for any 3D figure is correct or not by using this, like tetrahedron. We use this for tetrahedron. F plus V is equal to E minus 2. So check out if it is true or not. E plus 2, sorry. Clear? If you substitute here, what will you get? F is 6. V is, F means faces, that is 6. V is vertices, which is 8, and E is 12, and this is 2. So you can see here you have 14. On the right hand side as well, you have 14. So because F plus V is equal to E plus 2, that means the number of faces, edges, and vertices that you got for this figure is absolutely correct. And there are several examples you have of solid shapes. You have cone, which you can see here. You have cuboid, that we discussed just now. You have a sphere, that's a second figure. You have cylinder, here you can see that. You have cube, you can see here. You have pyramid. Like there are n number of examples that we can have when it comes to the solid shape. I hope solid shape is clear to everyone. That's 3D shape. It has got 3 dimensions, L, B, and H. And because it has got 3 dimensions, it will give rise to few other things, which are faces, edges, and vertices. Clear? So after this, what do we have? You have to practice these 3 problems as homework, guys. You have to do these 3 problems as homework. And in case you are not able to do them, or you face any problem while doing these problems or these questions, please get in touch with your askIITians expert. He or she will definitely help you out with that. Okay. So before we wrap up this session, let's quickly revisit the topics that we discussed. The first topic that we covered was how to find out area of any general quadrilateral. Then we discussed how to find out area of rhombus. We even calculated both the cases. Third, we discussed how we calculate the area of any polygon. We did problems based on all of them. And the last thing which we covered is what is the solid shape? Like what are the solid shapes? What makes a shape a solid shape? And what are the properties? What are faces, edges, and vertices? That's all we covered. And thereafter, these 3 problems are like homework for you guys. Please make sure that you all do this. And in case of any problem, get in touch with your askIITians expert. Clear? So that is this from this session. Thank you so much for attending. I'll see you all in the next one. Till then, take care. Goodbye.